In this lesson, we're going to talk about function. Okay, so this is the first time we talk about function in this course. So we're going to call it the introduction to function. So first, let's look at what's the definition of a function. The definition of a function is, first of all, a function is a rule. This rule that assigns to each element of X in a set of A exactly one element, f of X in a set of B. Okay, so suppose we have a rule here. This rule, we call it F. And this rule, okay, when this rule assigned to each element in the set of A, so this rule, if X is the input, right? Okay, this input is from a set of A. Okay, this symbol means belongs to, right? X is from a set of A. X is from a set of A. And the rule of this function, which is a rule, this rule applies to the input. It produces an output. This output is called f of X. And where does f of X belongs to? It belongs to a set of B. And this little symbol, okay, this little symbol, whether it turns to the left or turn to the right, it means to, wait, sorry. It means that it is from, it's from A or from B. Okay, so it belongs to. So this symbol belongs to. So for each element in the set of A. Now the question is, what are those elements in the set of A, right? So let's look at this with an example. Okay, we probably have seen a function that is a constant function, for example, right? And typically we use the notation y equals to c. What does that mean? Okay, c is a constant. C is a constant, meaning it can be any real number. It can be any real number. But once you decided to use a specific real number, say I'm going to use c equals to 2, then this rule as a function assigns each element, okay, each element. So the rule says the assignment to each element in A, 2, okay? So suppose we have a function here. So here we're going to introduce a little bit more notation. So this notation, I'm going to use the function notation here. Okay, so for each element from A, we don't know what A is. Okay, we're going to determine that. And we're going to make that assignment, that function assignment. And what does it produce? Okay, so this rule says every output is going to be 2. So for each input, okay, the output is going to be 2. The question is, what number can be qualified as input? And 2, of course, belongs to a set of B. So once we understand this rule will assign any input, any element in the set of A, exactly one element, exactly one. Okay, exactly 1. And here we have the exactly 1, that's 2. Meaning, if the input is 0, suppose I give 0 to be the input, the output is going to be 2. If I give the input -3, the output is also 2. If I give the input of 5, the output is also going to be 2. So that's the rule. That is the rule. A function is a rule. This kind of function is called a constant function. Constant function. So for each input, we have an output. And for each input, the output has to be exactly 1. Well, we only have 2. Right? So when we have this kind of rule, the question is, what can be qualified as input? So what is A? What is A? A, if we can identify all possible input, okay, such that for each of them, there's exactly 1 output. So we want to identify all possible inputs that this rule can apply, and that is called domain. That is called domain. I'm sure some of you have heard of it, right? So A is actually domain. If we make A to be all possible inputs such that for each of them, there's exactly 1 output. In our case, for this particular function, the domain is all real numbers, because we can assign 2 to each input, which can be any real number. How about the range? Range is about B, right? For each input, we assign the value 2. Well, certainly it's exactly 1. So B will make the range. In our case, the range is there's only just 1 number in the range. There's just 1 number in the range. So the range is made of only 1 number too. Okay, so this is the concept that from the definition of function, we want to identify domain and range. So now when we look at the function concept again, domain, so A is the domain, and B is the range. You can see once we have a rule, naturally, we will be asking the question, what can all the possible input be? And what are all the possible consequence, right? The range is a consequence of all possible inputs. So now we have a better understanding of this, right? So now let us do another thing, right? For each input, we have exactly 1 output. For each input, we have exactly 1 output. For each input, we have exactly 1 output. So how about we do something here? Is that we put the input output together in an ordered pair, inputs, output, right? So for input, for each input and its respective output, for the input 0, the output is 2. For input -3, the output is 2. For each input, for the input 5, the output is 2. And we can make many more of such points. And this ordered pair Okay, what is the ordered pair? Okay, we make the pairs in certain order, right? Input first, output second. Input first, so all of these are inputs. For each input, there's exactly one output. We have exactly one output paired with the selected input. So if we put all of these points in a rectangular system, guess what are we getting? We are getting the graph for this function. So we're going to take these 3 points. Okay, we're going to take these 3 points and we're going to make the graph for the function. Okay, so I'm going to take these 3 points. We can certainly make many more. We can make many more. Okay, feel free to make more if you wish. And I'm going to set up the rectangular system. Okay, don't worry about why I type y equals 0. It just gets started in the program. And so I'm setting up this rectangular system. I'm going to put the points in place. I'm going to put the points in place. Okay, and I would like you guys to take the notes and also plot the points along with me. Okay, so I'm going to plot these dots. So I'm going to add in the points 0, 2, input -3, output 2, input 5, output 2, and oops. Oh, this is the line. Okay. So we have 3 points. So you can see the 3 points. So if I make some adjustment, and we got all 3 points. Imagine we can make many, many points. We can make many, many points. If we connect all those points, all these points, they have something in common, right? They have the same output. For each input, there's exactly one output. And what is more, these outputs are exactly the same. What if we connect the dots? So if we connect the dots, and we got the graph of this function. This is the graph of the function. So this is an example of a constant function. Okay, so we can have similar, if your constant is 5, then you have, a similar graph, different outputs. So let's summarize. Okay, we study the definition of function. Okay, so we know a function is a rule that assigns to each element x in a set of A exactly one element called f of x in a set of B. So in our case, the function, which is a constant function, what it does, it assigns each input the value of 2. It produces a graph and we identify the domain and range. So when we summarize for this function, okay, we're going to talk about all these other functions later, okay? So when we summarize, so for this function, f of x equals to 2, and we have got the domain and range. The domain is all real numbers. And the range is just one number. Just one number only. Then here's the graph. Okay, as I have shown you earlier, okay, We're going to study all of these functions. Each one of them is a rule. Each one of them is a rule, okay? In the past, you're probably more used to this form, y equals to something. Now, I wish you guys to get used to using this new notation, which is f of x, right? So because these are the assignments, right? You assign the constant to the output, you assign x to the output, and so on and so forth. We can use y. You can just call it name y, right? So it's like in the process, you call it y from domain to range. You can call it y, or you can call it f of x. Why this notation is more advantageous? Okay, you're going to be using both in calculus classes. Okay, you're going to be using both in calculus classes. But each one has its advantage. If you use f of x as the output, you can see the input and output at once. Okay, you can see input and output at once. For example, in this notation here, I can also, I'm going to introduce another notation for you, right? See, the input is 0, the output is 2. I can simply use this notation. I can say f of 0, our input produces the output of 2. See? So using f of 0, right? You can use this notation. And over here, you can write f of -3. You read it as f of. Okay, then you mention the input. And the other one is that you can use the input of 5 and the output is 2. Okay, sometimes we don't mention, right? Sometimes we just use f of 0, replacing, just use that as the input output. So in this notation, as you can see, right, these notation give us great convenience. Okay, so you see this notation. In this notation, it tells you the input is 5 and the output is f of 5. Input and output given in one single notation, notation. Okay, so with all of these rules where we are going to cover, okay, we call these basic functions. So from now on, we're going to spend some time to cover all of these rules. Okay, and these two tables are really are the same tables. One, I use the output as y, and the other one I use the output as f of x. And they're really no difference. All of them takes input, but they have different domains and range. So we're going to study them one by one. Okay, so we just studied the first one. Let's look at the second one. F of x equals to x, or y equals to x. Okay, this table I call them all as basic functions. After we studied each one of these basic functions, and then we're going to study how we can generalize, how we can get more complicated functions. Okay, so these tables are called basic functions, and we're going to continue the study. The next function we're going to study is f of x equals to x, or y equals to x. Still with the definition of function in mind, okay, we bring the definition of function with us, and we're going to study the domain, range, and graph of the next function. The function definition, okay, which indicate we have input. The input is from the domain. And the function is the rule. The rule applies to the input. The rule applies to the input. It produces an output, f of x. And this output belongs to the range. So the next function we study is the function we called y equals to x. What does it mean? What does this rule mean? So, right, so this function is a different rule from the rule we just studied, right? How does it work? Okay, so let's first describe the rule. Okay? The rule, we're going to use f of x. Okay, so we're going to make that transition to use new notations. What does it do? For input, for any input, it produces exactly one output. Under this rule, okay, the output is going to be exactly the same as input. Okay, so this output is going to be exactly the same as the input. Input x, output is x. So what are the numbers that will be qualified for input? That's right, you got it. Domain, it will be all real numbers. Why? Because for each real number, you can just keep going. Right? So if input is -1, right? Under this rule, it will produce an output. It has to be exactly one output, right? So f of a -1 is going to be -1 because that's the rule of this function. So you see, we're using notation f of -1 is input is the same as output. So this output is the same as the input. And I can make the input to be, let me make the input to be, how about 0, right? 0 is such an easy number. So f of 0, the output is going to be the same as input. You see, that's the rule. The rule says the output is the same as input. This is the rule for this particular function. Got it? Therefore, any real number will do. Suppose I do an input to be 2. Then f of 2 is going to be 2. At this rate, do I get some points? So if we look at the ordered pair, right? The ordered pair, which is input, comma, output. For each input, if the input can be all real numbers, and what will be the range? The range, of course, is going to be all real numbers because each output is the same as its given input, right? So the ordered pair we get for each one of these examples we get here is going to be input is -1 and this output is -1. And input 0, output is 0. Input is 2, output is 2. So we can keep the list going. We're going to get as many points as you wish. We can get as many points as we wish. Can we choose the input to be fractions, decimals? Of course we can. Suppose I choose the input to be 2.5. No problem. Okay, input to f of 2.5. The output is going to be exactly the same because that's what the rule dictates. And the respective points is going to be what? 2.5 as input and 2.5 as output. Could the input be fractions? Of course. Can the input be fractions? Of course. We can have 2/3. Okay, the input is 2/3. And the output is exactly the same as the input. So we get another point. We get another point there. So how about we put these ordered pairs in a graph, in a rectangular system? Okay, so I'm going to move the domain and range to the top. And we're going to plot the points. We're going to plot the points. So you guys, please plot the points along with me. Okay. So I'm going to set up the rectangular system with proper, frame, legends, whatever. Right. So this is -5, 2, 5. And just make it a square. And layout. Now we're gonna put all of these points in place, okay? And you do the same on your paper, please. So let's do it together. Let's do it together, okay? We're going to add item. That's -1, -1. Another 1 point. I think we have a 0, 0, right? And we also have 2/3, 2/3. We have 2.5. We have 2.5 input, 2.5 output. There. So we got these dots. We got these dots. And we're missing 2, 2. One more. 2, 2. There. So we get all these points, all these dots. And what if we connect the dots? What if we connect the dots? We will connect the dots. And we get the graph. We get a graph. And if we wish to mark the points, which is usually highly recommended, right? We can mark the points. We can mark all of these points. So this point is -1 input, -1, -1 input output, right? You can see that 0, 0 input output. And over here, that's 2.5, 2.5, and 2/3. And I think this is 2/3. Input 2/3, output 2/3. So we got the graph for this function. So you can see a function, once a rule is determined, once a rule is determined, domain is determined then, range is determined then, and graph is determined then. But this graph, right? This graph is very illustrative, because what does it tell us? It tells us a lot of information, right? It tells us a lot of information. For example, as the input gets larger and larger, right? As the input gets larger and larger, and what happened to the output? The output is getting higher and higher. This is actually an increasing function. This is actually an increasing function, okay? And what else does it tell us? What else does it tell us? Well, if you look at this piece, right? If you look at this piece, after 0, 0, this piece, right? This piece after 0, 0 from here. Okay, so I'm going to use the red one. This piece, okay? There are many, many points on this piece. This piece indicates, what does it indicate? For all of these input, the output are what? Are positive. for all of these pieces, right? For all of these inputs, the output here, that's a negative input. So you can tell when the input is, when the output is positive for what inputs, right? So this picture tells us for these inputs, the output are positive, and for these input, the output are negative. And here 0, 0 is the point where it changes from negative to positive. Does that make sense? So picture could tell us a lot of information, right? So now we got the y equals to x. We got this function, right? So we get the function. So to summarize, right? For the function with the rule f of x equals to x, the domain is all real numbers. I know you might be thinking, could I use this notation? Of course you can use from negative infinity to positive infinity. The positive sign is optional here, actually. And you can also use that same notation for range, okay? You don't have to do both, but either one is fine, okay? And the picture. A picture tells 1,000 words, okay? A picture tells 1,000 words. So this is the picture. So this picture told us a lot of information, So this is the second example of function. So let's take the definition of function. We're gonna look at these other two, the second row, okay? F of x equals to x squared. Okay, so I'm gonna copy and paste the definition of function one more time because, well, actually I'm gonna do that every time because I want you guys to reflect on the words, okay? This definition of function, okay, it's just one sentence. One sentence covers so many functions and more, okay? And we will show you after we cover all of these functions, how we can produce more and more functions by adding, subtracting, multiplying, dividing, and a composition. Okay, that's what you have much to look forward to. So the next function we're going to talk about. So once again, we're going to identify the rule. Okay, we're going to identify the rule. And then we're going to identify the domain and range, and then the picture and the picture. Okay, so these are the three things we're going to do. And we're going to cover all of these functions. So we're going to get review all five, the contents from all 5 courses. Okay, now, so let's look at f of x equals x squared. What does this rule tell us? This rule tells us for input, the rule says, hey, you take the input, you just multiply the input with itself. That's what the input says. So this rule tells us to do that. It produces output. The output f of x is the square of the input. That's what this rule says. Okay, now, shall we identify the domain? What are the numbers that the rule can apply? And we want all of them. What are the numbers that this rule would apply and produces, right? For each one of the input, it produces exactly one output. That's right. Domain is all real numbers. That's right. All real numbers, i.e. from negative infinity to positive infinity. How about range? Will range still be all real numbers? Will range still be all real numbers? I'm going to leave a question mark here. So let's try out some inputs. Let's try out some inputs, right? So if my input is -2, so f of -2 would be -2 times what? -2 times itself. And what is -2 times -2? -2 times -2 is 4. So the input is -2, the output is positive. How about 0? Oops. How about 0? If the input is 0, we have 0 squared. 0 squared, of course, is 0. Now, what if I have an input 2? Well, maybe 3. F of 3 equals what? 3 squared. 3 times 3 is 9. If we keep going, we could have many, many points, right? We could have many, many points. And I would like you guys to take your time to, maybe you want to pause at this place, right? But we're gonna just do the usual thing and just plotting. So we're gonna do that ordered pair. Ordered pair. The ordered pair of input, comma, output. Input, output, input, output. So now if the input is -2, the output is what? Is 4. When the input is 0, the output is 0. When the input is 3, the output is 9. You see, when input is negative, the output is positive. When input is 0, the output is 0. When the input is positive, the output is also positive. Do you think we're gonna possibly get a negative output? I don't think so, right? So you think about the range. We're gonna plot the points. We're gonna plot the points. So y equals 0. So I'm just gonna activate the software's graphing tool. Okay, I want you guys to start plotting on your paper as well. Please do that. Okay, I'm going to make some adjustment to my view. Okay, maybe 10 here. So I got my, you see, why do I set my graph this way? Because I don't anticipate there's not going to be any negative number as output, right? So our range is not going to have a negative numbers. So think about the range, right? As we're plotting the points. So we're going to plot all of these points in the graph. You can plot more, please go ahead, do it. 0, 0. More points. 3, 9. You can certainly plot as many points as you wish. Okay, there. You can plot as many points as you wish. But because this function might be pretty familiar to many of you, so I'm not going to plot all those points. So I'm just going to connect the dots because most of us probably know this picture. X squared. That's the graph. That's the graph. you can see, okay, input, output, right? If you look at it from the input output perspective, input, right, for 3, 9, the input is 3, the output is 9. What is 3? What is a visual of 3? Well, this 3 is measured horizontally from the origin. And what is 9? The 9 is right here. The vertical measurement. So input is a horizontal measurement, output is a vertical measurement. And this picture tells us the output. The output is going to be vertical. So you're going to see many, many outputs. And none of these outputs is negative, right? None of the outputs is going to be negative if we plot those points. So this picture tells us the range is what? What should be the range? The range should be, if you say all positive numbers, that would be wrong. Because all positive number does not include 0. We have to include 0. So the range should be what? All non-negative numbers. Okay, so be sure. So how do we express that? How do we express that? Okay, so I'm going to clean this up. You see the picture, right? So I'm going to bring this back to our range expression up there. Oops. Oopsie, sorry. Okay, so for the range, I'm going to put it here to answer the question for range. It's all non-negative numbers. If you say all non-negative numbers, you are absolutely right. And you can also use mathematical notation to express that, including 0, which is from 0 to positive infinity. Because we could have 0, right? The output could be 0. But the output will never be negative. So we have how many ways to express the range? 1, 2. Are there more? Yes. Okay. The other way to express the range for this particular function, you can also write, because this quantity represents all possible, this represents the rule. So you can also say x squared is larger than or equal to 0. Do you see that? And this is actually a preferred. This is a preferred. Okay. And we can also combine domain and range in one sentence here. Okay. Domain and range in one sentence. Very useful sentence. Okay. Which is x squared is greater than or equal to 0 for all real number x. So this is the domain range together. See, here we addressed all the numbers, all real numbers, which is the domain. Okay, and range at least 0. I'm asking you guys to pay attention to these alternative notations. They're going to be very, very useful for you. Okay, when we use them, you should not be surprised. Another even shorter hand notation, and that will be, you can write this as for all real number x that belongs to all real numbers. You can even write it this way. So this is the shorthand notation to express the domain and range for this particular function. Okay, to summarize, right? We got the function. This is the function, domain and range. And we see something very interesting thing here from the picture, right? It looks like there's some symmetrical, it's a symmetrical along this line, okay? What is that? And the other thing is that if you look at the piece, right? If you look at the piece, there's a piece on the right side and there's a piece on the left. The piece on the right, the lowest point is 0, but other than that, this piece is positive, 0, positive. So the entire piece is no lower than the x-axis, okay? No lower than the x-axis. So a picture tells us also it is symmetrical. It is symmetrical, okay? All right. Let's move on to another function.